Hey guys, for today's lesson, I'm going to do something a little different. I have a few special guests that I would like to bring on to the lesson for today. They're a little nervous though. They've never actually made an appearance before on camera, and so when it's time for them to come on, we may have to encourage them a little bit. But nonetheless, I'm excited to have them onto the show. I think that they're going to add a lot of good content to the lesson for today. They'll bring in some good insight for you as well. So today's topic is about capacity. Now, before I even explain what capacity is, I want to see if you think you can define what it is. Of course, I've put a little visual cue here in the background of my title slide here. And so I want you to just have a look at this picture here. Take a look at what's going on and see if you can come up with a good definition of what capacity means. Okay. All right, you got your own idea of what it means in your brain. Well, let's move on because in just a few short seconds here, we are going to talk about what capacity is. So, your learning goals for today. Today, I'm breaking a new record. I've actually put 3 learning goals on today's lesson because, well, quite frankly, they're all really, really short goals, and I think we'll be able to master all 3 of them today. So, goal number 1, I can describe the relationship between milliliters and liters. Goal number 2, I can select reference for milliliters and liters. So we'll be able to choose like real world objects that may help you kind of identify how big a milliliter and a liter is. And lastly, I can estimate the capacity of given objects using milliliters and liters. And so when everything's said and done, hopefully you'll be able to look at everyday objects that you have kicking around your house and you'll have a pretty good idea, a pretty good estimate of what that object's capacity is. Okay, so let's have a look at capacity and what it actually means. And this is actually really relevant for what's going on around in the world with the COVID virus. And I just read an article the other day that said restaurants are going to be starting to open up pretty soon, but they're only going to be allowed to have half capacity, or in other words, a way of saying that is they're only going to be allowed or allowing about half of the number of people that they're actually able to hold in there. So they've got a capacity, an amount of people that they're designed to hold, but when they reopen here, they're only going to be operating at half capacity, which means basically every second chair is going to be empty. All of this in an effort to try to limit the spread or reduce the spread of the coronavirus if there's another outbreak. So capacity is just basically figuring out how much something can hold. Now, in here, in my definition, I said when you fill a container, but you'll notice I put like bunny ears around container there because a restaurant isn't really a container. I guess it's kind of a container for people. But so a lot of times when we're measuring capacity, we are measuring containers, things that you might find in your fridge or your bathroom or whatever. But it doesn't have to be a container. It can be a restaurant, a building, an elevator. You know, elevators have capacities as well. But yeah, you're basically just figuring out how much a container can hold, and that's what its capacity is. Okay. Now, let's start with some really familiar items here that you probably interact with every day. All right. So milk jugs. Um, that they've got the big 4-liter milk jugs here, and so this jug is the capacity of that jug is 4 liters. That's how much it can hold when it's full. Of course, they've got smaller jugs there, which are 2-liter jugs, and maybe you've seen these skinny ones as well. These are actually 1-liter jugs. Okay, so this is just to give you an idea of what 1 liter looks like. It would be one of these small milk jugs. Um, and of course, so that was one of the things we wanted to look at today was like, what's a liter? Choosing a reference for a liter. But of course, milliliters as well. And so milliliters are actually smaller than liters, just like millimeters are smaller than meters. So anytime we see that prefix of milli in front of a unit, that usually means it's a smaller amount. Okay, so couple other things you may be familiar with, especially if you've done any help in your house with baking, are measuring spoons and measuring cups, right? So if you've ever done baking or even made craft dinner, I'm sure, if you've read the instructions, it'll say like, add a cup of milk or maybe add a tablespoon of butter. So this over here on the left side is a teaspoon, 1 teaspoon, and 1 teaspoon is actually equal to 5 milliliters. So if you were to take the amount of like water that this little spoon holds and divide that into 5 equal sections, each one of those little subdivisions, 1/5 of that would be equal to 1 milliliter, just to give you an idea of how small a milliliter is, okay? There's, of course, a bigger spoon that we could use to measure. So bigger than a teaspoon would be a tablespoon. And 1 tablespoon is actually equal to 15 milliliters. So yeah, you can probably do a little bit of mental math in your brain there and figure out that a tablespoon is 3 times as big as a teaspoon, okay? And then, of course, we also have just a standard measuring cup. And I don't know if you can see, um, this is actually kind of a bad example. I just grabbed this off of the internet, but it says 1 cup on the handle and then it says 240 milliliters. And I'm not sure what's up with that. I actually just realized that right now in the recording, but it turns out 1 cup is actually equal to 250 milliliters. And if, well, okay, here's special guess number one. I brought my very own measuring spoon and you can see, measuring cup, sorry. You can see there's a 1 on the handle here. That lets me know that it's 1 cup. And then in very small print right here on the handle, it's etched into the metal. It says 250 milliliters right there. Okay. So that's proof that I do know what I'm talking about and the internet does not on this video here. Okay. All right, so let's put all of these together, guys, from smallest to largest. So we've got 1 teaspoon, which would be the smallest referent here. And of course, even this teaspoon is bigger than a milliliter. We talked about how this is actually 5 milliliters here. Then we've got a tablespoon, which is 15 mils. And we've got a cup, which is 250 milliliters. One of our goals for today was understanding the relationship between liters and milliliters. And so I do want to point this out, and I have it highlighted here, that 1 liter is actually equal to 1,000 milliliters. Okay, and I don't know if you remember earlier in this unit, but I was talking about how our metric unit is really, really easy to use, because when we were talking about measuring distances, we said that there are 1,000 millimeters in a meter. Well, it's kind of the same conversion when we're dealing with volume and capacity, guys. It's 1 liter is made up of 1,000 milliliters, okay? So these two volumes or capacities are the same amount here, all right? But then, of course, we work our way up to the top of the scale here, all the way up to 4 liters or 4,000. I'll just move my face here, 4,000 milliliters. Okay, so now that we understand what a milliliter and a liter is, and we've chosen reference to kind of help us identify how much space each one of those units of measure would take up, now we're going to get into that third learning goal for today, which is estimating the capacity of random objects using reference. Okay, so my favorite drink, guys, is Coca-Cola. All right, I actually, if my wife prevents me from drinking more than one a day. But yeah, I generally have one of these per day with my lunch. And so what I want to do, guys, is I want to estimate how, like, the capacity of this can of Coke. Now, to help out, so these are my special guests, by the way. These are the guys that are going to help us form a little bit of an understanding here. So we've got my 1 cup measuring cup here. We've got a pop can, and we know that this is 250 milliliters. So based on that, can we estimate the size of this pop can? I'm just going to stick it right inside there. All right. So I know that my measuring cup is 250 milliliters, and based on how big my pop can is, that looks like it's probably about twice as big, maybe. It's more than twice as tall, but the measuring cup is also bigger around, so that's going to kind of factor into my estimate here as well. So I'm going to say this is about twice as big as this. So if this is 250 milliliters, I'm going to say, hey, my estimate, the best number I can come up with here is 500 milliliters for a can of pop. And it turns out that, like, anything that you buy in the store that has capacity, it'll actually list the capacity right on the container here. So if you look closely at the bottle or the can here, you can see right down here, you're kind of getting a weird glare, but right where my finger is, that says 355 milliliters. Now, I estimated 500. I was a little bit too, my estimate was a little too large, but it was pretty close, right? 500, close to 355. I don't know. You be the judge. Okay, so that's special guest number one. Special guest number two would be my child's toothpaste. All right, I was just going around and grabbing random things, so please don't question my judgment here. But this is toothpaste for my son, and again, I'm just going to estimate the capacity of this. So here's my 1 cup measuring cup, and again, this is quite a bit taller. The toothpaste is quite a bit taller, but if I tilt it to this angle of it, you can see that that toothpaste actually doesn't, it just takes up a very small fraction of the footprint of my cup. So I don't know, I could probably chop this toothpaste in half, um, stick the top half down in the measuring cup here as well, and there'd still be plenty of room left over. So I would say that this is roughly about half the capacity of my measuring cup. So I don't know, 250 milliliters, and half of that would be about 125. So that's my estimate. And then it turns out if I were to go and look right on the container down in the corner, it has a capacity of 100 milliliters. So I guessed 125. It's actually 100. That's a fairly reasonable estimate, right? Estimates don't have to be exact, but they're just close. Okay, that's enough yapping for me. I did bring in a couple more special guests. I just went into my recycling bin and pulled out a bunch of random objects. This, I don't have to estimate that. I know exactly what that is based on this video. That's a 4-liter milk jug, or 4,000 milliliters. And this one, if I were to hold it up to the milk jug, it's not nearly as big as the milk jug. The footprint of it is quite a bit smaller. The height is quite a bit smaller. I would actually say this is about 1/4 of a liter, or sorry, of a 4-liter milk jug. So I would estimate this probably has a capacity of 1 liter. And I'm getting good at this. I am, because you can see the capacity printed right on the jar here. 1 liter. Okay. Capacity. That's your lesson. And now for your assignment for the day, guys. Your assignment will be find 5 bottles around your house. They can be big ones, they can be little ones, they can even be bigger or smaller than the ones that I have here. And what I would like you to do with those 5 bottles is arrange them from smallest to largest capacity. Then, just like I estimated capacities using reference, I would like you to estimate all 5 of your bottles' capacities. And then once you've recorded your estimate on the assignment, which I will post in Google Classroom, then I would like you to search the label of your jugs and see if you can find the actual capacity on your jug. 99% of the time, guys, you'll be able just to find the capacity on the jug, but every once in a while, you'll find a jug that doesn't have a capacity. And if that's the case, then what you can do is you can fill up the jug, and you can use measuring cups, like if you've got a 1-cup measuring cup, and you can pour out the water into this until it's full, and then dump that out, and then pour it again until the measuring cup is full, and dump it. And just keep track of how many times you can completely fill the measuring cup, and then multiply that number of times by 250 mils, all right? And that'll get you the capacity, just using a little bit of math. All right. So that's your lesson today, guys. It's also a pretty quick, easy little assignment. Go have some fun with this. Be creative, and try not to find 5 bottles that are all the same size. Okay. Find a nice range for me. I can't wait to see what you guys come up with. We'll see you later.